All right. Again, thank you very much for joining us and happy National Invasive Species Awareness Week. Hopefully everyone is doing something with your local SISMAs to help support and increase awareness on invasive species and their impacts across the landscape, especially here in Florida. Our monthly webinar is hosted by FISPAC, which works to facilitate partnerships that prevent and control the threat of invasive species on public and private lands and waters here in Florida. So thank you very much for making time. Our presentation agenda for today, I'll give a brief welcome here, and then we'll hand it over to Dr. Pam Knox, who's going to talk about, I think, a very timely subject for us, the potential climate change impacts to herbicide application. Then I'll give some brief FISP and SISMA updates. Just some housekeeping notes as we go through the presentation today. Please keep yourselves muted. If you have any questions, feel free to throw those in the chat as we go through the presentation, and we'll address them at the end. If you have any issues, you can message me directly through the chat. So at this point, I'll go ahead and stop sharing and hand it over to Dr. Knox as I introduce her. Pam Knox is the director for the University of Georgia Weather Network and an extension climatologist specializing in agriculture and climate. She has served as the Georgia Assistant State Climatologist and Wisconsin State Climatologist and was an author of the Southeast chapter of the 5th National Climate Assessment published in 2024. And she's got a great presentation ready for us today.
All right, hopefully you should all be able to see that by now in dark blue.
Yes.
And I don't know that I'm gonna talk for 35 minutes, but I'll talk for a while, and then hopefully we'll have time to talk about some questions at the end. So you can hear that even though I've been in Georgia for over 20 years, I still I sound from the Midwest, and I actually grew up in Michigan and went to graduate school in Wisconsin. I have never shaken that accent. So I'm not really a Southerner by birth. Throws some people off, but happy to be living down where it's nice and warm, and we're not a month away from spring yet, which is, my mom is up in Grand Rapids, Michigan, and it's still really cold up there. So I'm happy to be here today. All right, let's see if I can get this to advance. There we go. All right, so I thought this is kind of an outline of what I'm going to talk about for the next 20 or 25 minutes or so. First, I want to talk about how herbicides are affected by weather and climate, because if we're going to talk about changes, then we need to know what the impacts of those changes might be on herbicides. And I am not an expert in this by any stretch of the imagination, but I can do some research, and so I've done some research on some of the impacts you might expect to see from different kinds of weather and climate, and how they would affect herbicides. And then I want to talk a little bit about what is climate. And we're going to talk here about current climate. Then we're going to talk about how the climate is changing and how that might be affecting plants and, by association, herbicides. And so we'll talk about changes in climate that are occurring and how that might affect the effectiveness of herbicides. And then, since it is Invasive Species Week, originally I was going to do this jointly with another speaker, but I'm going to try to jump in here and talk at least a little bit about invasive species and how that all kind of factors in to climate change and herbicide use. So first of all, let's talk about how herbicide application is affected by weather. Of course, climate is sort of an amalgamation of weather over a long time period. Or as one of my third grade students told me in a class that I was teaching a couple of years ago, climate is the clothes in your closet and weather is what you put on today, which I thought was pretty good for a third grader. And so we're going to talk about the effects of weather and, of course, by association, climate as well, since that sort of integrates the weather over a whole year. First of all, we know that warmer temperatures generally enhance herbicide absorption. But if it's too high, then the herbicides become more volatile and they evaporate before they can really become effective on the plants. And so the temperatures that we have will affect herbicide effectiveness. And obviously, you can enhance that somehow by picking temperature conditions that are going to be the most effective for the herbicides that you're using. But in general, we're going to see there is a change, and that is probably going to affect the herbicides we have. We know that if rain falls right after you apply a herbicide, that tends to wash it away before it can really make good inroads into the plant, and that will reduce the effectiveness. So rain amounts and rain frequency are both important when we talk about herbicides and climate change. We do know that wind can cause spray drift. This is a problem in a lot of agricultural applications because they may be putting some kind of herbicide on one field, and if it's windy, that will blow into the next field where there might be a different crop, and so that will have some issues for the farmer that's downwind. Now, wind is something that's not often discussed in climate change. I think in general, winds are expected to be lighter for most of the year, but I'm not going to say a whole lot more about wind than that because we just don't really know. Higher humidity is something else. We know it's going up now, and higher humidity is known to increase some crop injuries because the herbicide droplets stay on the leaves and they don't evaporate. They just stay on the leaves longer, and sometimes that can cause some injury for some herbicides. Then if we look at a little longer term conditions, if we have drought in the area, and of course droughts are a natural part of climate variability, but droughts are also expected to change over time, especially as the temperatures get warmer. And so that means that we may have to use higher doses of herbicide to compensate for reduced uptake by the plants if they're struggling because of the dry conditions. And then pre-emergent herbicides, the one I think of is the one you use for crabgrass in your lawn. You have to get it in, you have to have it applied before the temperature gets above the germination temperature for whatever it is you're trying to kill. And that will depend on the particular weeds that you have. I know up here in Georgia, it's probably almost already too late to put in anything for crabgrass because we've been up in the 70s. We're going to be in the 70s again today. And so I think we're past the point of, getting past that germination temperature. And so I think we're kind of stuck. I have mostly moss in my yard, so I don't worry too much about crabgrass, but that would definitely be something people might have to worry about. All right, so let's jump in and talk a little bit about what climate is. I spent a lot of time looking at graphs and maps and so on, so if you're not used to doing that, I will try to explain what's shown in here. The basic idea is that climate describes what's going on as far as the atmosphere goes in one place over time, or what's happening over an area, like a state or a country. And the two graphs, or the two figures that I have here, the first one is the Georgia average temperature, which is every year's annual average temperature going back to 1895 to the present, and it's just one number per year. You can see there's a lot of year-to-year variability that causes a lot of problems for the farmers because whatever happened last year is probably not going to happen this year. Pretty rare to have 2 years that are exactly the same, although even that has happened a few times. If you want to get it from Florida, then you can go down to the website at the bottom, or you can just Google climate at a glance, and you should be able to find the website that will allow you to do a similar kind of timeline for Florida, or you can even break it down and do it by a smaller part of Florida as well. And so that's something that you could certainly use. There's a lot of different things in here. I could talk for 20 minutes about this graph, but I'm not going to. But some things that you might notice that there's this period from about 1895 to about 1925 or 1930 where the temperature is maybe going up slowly. And then from about 1925 to about 1970, there's a decrease in the average temperature, annual temperature per year, even though there's still the variability, but there's that long-term trend. And then since about 1970, we've had a definite increase in the temperature. This is true of every month of the year. It's true in both the daytime maximum temperatures and the nighttime minimum temperatures. And that 1970 turns out to be an important year because that was the year the Clean Air Act came into effect. So the Clean Air Act was written by Richard Nixon and effectively cut down on the amount of particulates that were being emitted by coal plants in the Midwest. And all those coal plants are upwind of us here in the Southeast. And so all that black soot was coming over us, and that was blocking sunlight from getting to the ground. So at least part of that cooling was related to that. I think it was probably also related partly to the change in agriculture from more bare ground crops to more forest. Georgia now is like 65% forested. Um, and so that also helped to cool things down. But since 1970, the air's been cleaner. We've had more urbanization, so that's certainly influencing things a little bit, although this is based mostly on rural stations. Um, and we've had, you know, the change from bare grounds to forests has mostly already occurred, and now we're starting to go back in the other direction. So the other figure on here is a map. This one happens to show last year's total January through December county precipitation rank. So the darker the green, the more close to the wettest year on record it is. You can see in eastern Texas there's a few counties that were the wettest on record for 2024. Here in Georgia and in Florida, you can see there's a lot more wet counties than dry counties. So it was 2024 was generally a pretty wet year. Not surprising when you think about, we got hit by several tropical storms and hurricanes, and that brings a lot of rain in a short period of time. So that is not surprising. Although in between those hurricane events, it's been pretty dry. And so sometimes that annual average or the annual total amount isn't always a good representation of what's going on. So these are just two different ways of looking at climate. One is more based on a particular location. The other is based more on patterns over space as well as time. And climate is defined. If I ask you to describe what climate is, you might say, oh, climate is the average weather. And it's true that it's the average, but it also encompasses things like extremes and ranges and cycles and trends. And so all of that is describing what the climate is like. Now, if we look at the climate at a particular location, this is a graph that's called a thermograph. I did it for Macon because it's in the center part of Georgia. Again, if you go to the website that's down here, which is now the Midwest Regional Climate Center, you can do one for your own area as well. I encourage you to do that. Let me just talk you through this because there's a lot on here. The green band is the average high and low temperature for the last 30 years. That's called the normals. The red on top is the daily extreme highs for each day of the year. And the blue is the daily extreme lows for each day of the year. This is for the Macon area. It includes both the Macon city record and the airport record, which they switched about 1930 or 1940. So this kind of encompasses that all. And then on top of that, you can see the gray bars, which are what happened in 2024. And there's, again, a lot of things there. You can see, especially in spring and fall, there's a lot of variability associated with fronts coming through the area. So we have cold, we have warm fronts moving in from the south. We have cold fronts coming in from the northwest. And that brings those changes, usually quite variable in the spring and fall. But in the summer, we don't really see that. In the summer, we see much more uniform temperature ranges over, and then, there's still some variability, but overall, definitely less day-to-day variability in the summer. So that's what our climate is normally like. If you look carefully, you can look at the summer and you can say, well, it looks like there's more days that are a little above the green band than below the green band. So that is one indication that we're going towards a warmer climate over time. But, on daily records, it's a little hard to discern that because there's just so much variability. So how is the climate changing? These are a couple of figures that show for the whole country what the changes are in annual temperature and in annual precipitation. Let me start with talking about the temperature. You can see everywhere in the United States is getting warmer. This is consistent with what's going on in the rest of the world. Temperatures are increasing, except you'll notice that there's some blue areas in the southeast. And that's because this particular map goes all the way back to 1895 and includes that period before the Clean Air Act was in effect. So that blue area is really reflecting some of the cooling that was occurring from before 1970. And since that's gone away, that blue area is kind of filling in with pink and red. And so really even the southeast is getting warmer now. If you just did the last 50 years or so, you would see that that's changing. Winter temperatures are getting warm faster than summer temperatures are. In fact, it's really interesting to look at the summer temperatures because there's a lot of the country that's really not getting warmer. That probably has a lot more to do with irrigation of crops than it does anything else. Because when you put out all that water, you're essentially cooling the air by evaporation. And so the summer is not cooling as fast as the winter is. The winter, another issue is lack of snowfall. Usually in Michigan, where I grew up, we get 40 inches of snow every year. And that's getting lower over time as things warm up. Although surprisingly, not getting lower as fast as you might think because the lakes are staying warm. And so when we have really cold air coming over the lakes, we get a lot of lake effect snow in western Michigan. And so they're getting quite a bit, even though the climate as a whole is getting warmer. So it's not an easy comparison between snow and climate change because you have to think about how the snow is forming. If we look on the right-hand side, the annual precipitation, you can see most of the country is showing green, which means it's getting wetter over time. We're kind of in a area where it's been drier than usual. That's because in the last 20 years or so, we've had quite a few droughts in the Southeast. And so I think it's a little bit reflecting what's happened in the last 20 years instead of the last 100 and some years. But we are also in the Southeast getting warmer or getting wetter now in most parts of the Southeast. And that's because there's more humidity in the air than there used to be. So there's more chances for rain to fall. And when the rain falls, it falls heavier. And we'll talk about that more in just a minute. Winter precipitation, you can see, varies quite a bit. In the spring is dry in the Southeast, but very wet up in the north. That's because they're getting more air coming in from the south than they used to, more humidity with that. Here in the Southeast, it's also a bit drier than the trend is towards drier conditions, except for southern Florida, where they're probably getting more hurricane rainfall. And fall is a big increase in rainfall everywhere except for the Florida peninsula. And that is partly due to more hurricanes, or at least more rainy hurricanes, not necessarily more in number, but all those things are falling. And so that's changing patterns. The fall precipitation is good for some things like growing peanuts because they need that rain to fill in the pods, but it's not good if you're trying to harvest cotton because the cotton is much easier to work with if it's dry. So those are things that we're looking at. If we look at how it's expected to change in the future, this shows some different scenarios for the amount of warming that we're likely to see. This is annual average temperature, so keep in mind year to year is going to vary from this. If we look by the mid-21st century, about 2050 or so, you'll see it really depends on how much carbon dioxide and other greenhouse gases are being emitted, because you have to use two different scenarios depending on what you think humans are going to do about changing the amount of fuel and energy that they use or how much greenhouse gases they put out. In either case, it's going to get warmer, but it's going to get warm a lot faster in what we call the higher scenario, RCP 8.5. Because of work that people have already done, switching energy sources from burning coal to doing more things that are energy friendly to the environment, like solar and wind, we're probably not going to get to 8.5, and that is a good thing. But we still have a long way to go before we see where we're going to end up. And then by late in the 21st century, so 2100 or so, you can see that those differences in temperature have changed quite a bit. The Arctic changes the most, and that's not surprising, because there we're looking at not only the changes in the air temperature, but also changes in the amount of snow and the amount of sea ice. And as it gets warmer, those disappear, and they're much brighter and more reflective than the ground is. And so if you get rid of that really highly reflective surface and turn it into something that's pretty dark, it's going to absorb a lot more of that sunlight that comes in. And so we do expect that the Arctic's going to warm up a lot faster. And we're seeing that now. That's not something that's a surprise. That's just basic physics. So the climate models tend to predict things that are easy for them to predict, like average temperature. Is not always the most useful for people that are working with plants or working on shorter time periods, because there's a lot of variability, and that is what causes a lot of the issues. Okay, if we look at changes in precipitation, here I have it broken down by the seasons. We already know that it's getting wetter, and that was based on data. That wasn't based on the models like these are, but the models say we're expected to see increased changes in precipitation in really most of the seasons, but especially in the winter and spring. Here in the southeast, the summer and fall could be pretty close to what it is now, maybe slight increases, but we're already pretty wet. The average precipitation in Georgia is about 50 inches a year. I think it's probably just a little higher in Florida, but it depends on where you are in Florida. So that is not going to change tremendously. What is going to change is how it's falling. We do know that the average annual rainfall is not changing that much, but when the rain falls, it's falling harder and shorter, like more thunderstorm kind of rain, more hurricane kind of rain, which means that if the annual average is the same, or the annual total is the same, but it's coming harder in shorter periods, it means there's longer dry spells in between. Might be a good thing for herbicides because you'll have more time to get your herbicides out before they would have the potential of getting washed away. Of course, timing is always an issue for that. So we see a change in the number of days with 2 inches or more. So that's kind of considered the heavy rain. In the southeast, we see a 27% increase in that. The other parts of the country have even more, especially in the northeast, where they're going from more snow to more rain, and so the changes are quite a bit. And a lot of our infrastructure, like culverts and highways, are not really built to handle that heavier rain. So we're going to see more frequent flooding. Not really a big issue for herbicides, of course, unless you're worried about transportation, but definitely something that will cause problems for you trying to get around on a daily basis. One of the examples of this change in temperature, especially, is the changes in the plant hardiness zones. If you are a gardener, you know that every plant is designated to be able to survive a certain number of hardiness zones. The hardiness zones are based on the lowest average temperature per year of the location. So it's based on temperature, but it's not directly based on the annual average. It's based on something a little different than that. It was just updated in 2024. And so you can see the smaller map on the left-hand side there, so it shows that changes. Most areas of the country, the areas that are in tan, are areas that got bumped up one category. So they might have got bumped from 7A to 7B, or from 7B to 8A, or something like that. And those are all based on particular temperature ranges for that lowest minimum temperature. And so you can see now there's quite a gradation across the northern part of Georgia, which is mountainous, down into the very southern part of Florida, where it's tropical all year and they almost never see snow. So that has been updated infrequently, but the newest one came out just a few months ago. If we look at what plant hardiness is likely to be in the late part of the century, so 2070 to 2099, you can see those zones are going to continue to creep up. So now Georgia is either mostly zone 8 or zone 9. Doesn't break it up by A and B here. Zone 9 is really considered to be a tropical storm or tropical ecosystems, or plant hardiness zone. And so that is something that means they're probably not going to see freezing temperatures necessarily every winter. So that is something that will just have to be watched. If you look down into Florida, of course, you become even more tropical as you go farther to the south. So that is something that affects people who are working with plants, because the kind of plants that you grow is going to depend on what these hardiness zones are. And as we go towards warmer zones, we're going to see some issues with more invasives coming in that are tropical in nature and can survive those temperatures in the future that maybe they couldn't survive now. So if we look at how climate change is affecting gardening and agriculture, a number of different things sort of pop into mind here. The average climate conditions really determine what kind of crops you can grow. So that includes things like the plant hardiness zone, what the coldest average temperature is per year, how hot it gets too, because some plants don't do very well in really high temperatures. And of course, there's other factors as well, like soil types and the availability of water. Transportation to markets is more of an issue if you're growing for profit. If you're a farmer, or if you sell at a farmer's market or something like that. So then transportation becomes more of an issue than if you're just growing at home because you like gardening. Um, Climate variability, the ecosystems depend on a variety of climates, and that includes droughts and floods. But for most food systems, agriculture likes it to be the same every year because it's much easier to manage than having to manage this constantly changing weather going back and forth between cold and warm. Extreme cold, the frost and freeze determines the length of the growing season. We're looking at here now because we had a frost late last week, and a lot of our strawberry producers were irrigating, or they're putting covers over the strawberries to protect them from the frost. Our blueberry producers are, especially in South Georgia, the plants were just blooming because we had a cold January, but a pretty warm February, especially early in February. And the plants broke dormancy and they started putting out flowers, and then the frost came. And if the flowers freeze, they have lost their crop for the year overnight. And so it's definitely something that's been of concern here. And so that is something to keep in mind. Extreme heat, on the other hand, and humidity as well, because humidity is going up, provides heat stress to livestock, some crops like corn, and farm workers. So all those things are things that we have to look at when we're talking about climate change and what the impacts might be. So just a few other things that I kind of just threw in here from another talk. Change in the season of the frost-free. We're going to see longer growing seasons than we have in the past. Longer growing seasons are good if you're going to try to double crop, or if you want to grow something that takes a little bit more time. But it also means it's going to be a longer period that you can have the growth of invasive species, insects and plants. And so those are things that we have to worry about. The number of frost days is going to go down. That means some things are going to be able to overwinter better than they could. It's going to be something that we're going to have to address earlier in the spring with herbicides or pesticides or whatever. Change in the number of consecutive dry days you see here, as we mentioned before, it's probably going to go up. So that will have some mixed blessings because that will allow you more time to maybe get your herbicides on, but at the same time, it's going to mean droughts are more frequent. And so that is something that will stress the plants that you're applying on. And the change in the number of hot nights, it's going to be, the daytime temperatures are going up, but nighttime temperatures are going up twice as fast. And that's because the humidity that's increased is not allowing the temperatures at night to drop down to cool conditions. And so nights are getting hot much faster than days are. And that humidity will also cause problems for things like fungal diseases. So if you're worried about dealing with fungal diseases, that would be an issue. We do know that there will be higher carbon dioxide. That does slightly increase the crop growth, but only if you have enough water. If you have enough water, then you get some benefits from that. Unfortunately, things like poison ivy seem to do even better in high carbon dioxide than most other plants do. And so that is something it's kind of a mixed blessing, I would say. Changes in ag and climate affecting herbicide use. These are some things that I think we'll have to think about as far as herbicide use goes. The warmer temperatures could increase effectiveness in some places because maybe the temperatures will be in the preferred zone for longer. Of course, again, you can control some of that by when you apply. But if it gets too hot, then it's going to volatilize and it might not be as effective. And I'm sure there are options. You can go find different herbicides that might work better, but it's something that might be more expensive to do. The longer dry spells could mean wider windows to apply because you don't have to worry about the rain washing it off. But if it's dry and it's droughty, that might reduce uptake in some of the plants. And so that would certainly be an issue. You might have to put on more to make it effective. Higher humidity could reduce the evaporation of droplets. That could increase the damage. And so that would be something you'd need to keep in mind. Wind, as I mentioned before, we don't have a lot of information about how the wind might change in climate change. Generally, I think people would expect them to be lighter. But if there's more severe weather, then of course those will be high winds in those situations, even though in between it might not be very windy. And then I want to just close my part of the talk here by just mentioning invasive species. as the climate changes, the temperature and rainfall characteristics that we have here in the Southeast are going to become more welcoming for different kinds of tropical species. And they may grow better than our native species do, because the native species are adapted to what the climate was and not necessarily what the climate is going to be. And so that gives the invasives a chance to grow better than the native species do. And so that is something that will have to be taken into effect. Also, the invasive species might not respond as well to the herbicides that we've been using in the past. And so we may have to think about different herbicides or different ways of treating those invasive species than we have in the past. And so that's something that you will have to keep in mind. You might have to talk to your friends down farther to the south and see what are they using to deal with these particular weeds and plant pests, or insect pests for that matter. We do know that the warmer winters overall are going to reduce the winter kill of tropical plants. It means things are going to last from one season to the next more frequently, and that will carry disease from one growing season to the next. And so that will be something that means we may have to use more herbicides than we did in the past, because we're going to have to deal with those plants growing all year instead of just part of the year and being killed off by the freezing conditions. Also want to keep in mind that climate change doesn't just affect the plants, but it also affects the workers. And so because it's getting a lot hotter and we're having days that are above 90 or 95 degrees, that's going to increase by quite a bit. So that is going to affect people's ability to work outside for long time periods. If you're just gardening occasionally, or if if that's not your primary job, you could probably work around that. If you're running a farm, you might have your farm workers start work earlier in the morning, maybe even overnight where it's cooler, although it's also more humid, and having them work by lights so that they can rest in the middle of the day when it's really hot. So there are ways that you can manage that, but they come at some cost. And so that's something you need to keep in mind. You can also do more automation. They've got these cool things now where they have lasers that will go in and shoot the weeds that are in fields. It's more automation, but that's expensive, and it can use more fuel too than having people. So there's a cost benefit analysis that has to be done there. And then we also have to think about what's happening in other parts of the country and other parts of the world. Here in the Southeast, I think we're relatively well off because we have quite a bit of rain. The temperatures are going up, but they're not going up dramatically so far. But other parts of the country, including places where a lot of our food comes from now, like California, are going to be a lot worse. And so a lot of the food that's produced in California now may not be able to be produced there in the future. And we'll have to figure out where are we going to get our broccoli. If you're growing in your garden, that's good enough, but you can't really feed the whole population of Georgia or Florida by growing broccoli in your backyard. For one thing, broccoli likes cold weather better. But you can see some of the crops here that are grown in California, a lot of nuts, broccoli, strawberries, and grapes, and so on. All that's grown out there, and none of that may grow there in the future. So you have to think about not only what's happening in your own place, but also in other places where we get these different foods. So if some of that production moves back to the Southeast, as it could, because we'll have the water, we're going to probably have to use more herbicides and pesticides than they do in California, because there it's pretty dry. They don't have to worry about a lot of fungal diseases and so on. But here in the Southeast, that's definitely a concern that we're going to continue to have. So that's all I have for my presentation, and I am happy to take some questions. If you are interested in learning more about your local weather, you can use the Weather Service. You can use the Midwest Regional Climate Center. There are also mesonets. I run the mesonet here in Georgia at weather.uga.edu, but there is one in Florida as well called FAWN. And that will give you not only some of the weather information, but also information about soil temperatures, which might be useful for planting or deciding if you're going to use a pre-emergent. Probably too late for that, but. All right, so I'm going to go ahead and stop the share, and we'll see if anybody has any questions.
Fantastic, thank you. We don't have any questions up. We just got one coming into the chat. Perfect. So the question is, dealing with invasive species in Florida is just going to get worse overall?
Uh, I think probably it is, because I don't see any way to keep them out. The invasive species can come in a lot of different ways. They can blow in on the winds. We know that diseases now are blown in from Mexico on the winds coming from the southwest. Every year we have things like rust on corn. So that's already blown in. And some of the invasive species, either the spores will blow, or if it's insects, they might blow in. Of course, transportation of food in and out is something that also brings in invasives. And so I think it's gonna be really hard to keep them from coming in, because you really have to work hard to keep them out.
There's a lot that goes into prevention for sure.
Yeah,
I have a question. I've really been noticing kind of that feast or famine aspect in the last few years for our rainfall. And I attend some of the monthly climate webinars that I know you're a part of, and I find those very, very valuable.
yeah.
One of the concepts that's been new to me is flash drought. Can you talk about that a little bit?
Sure. A flash drought is something that really was never talked about in scientific literature until the early 2000s. But the idea of it has been around for a long time. Flash drought is a drought that occurs very rapidly over time. So, and it's mostly an agricultural kind of drought because it's the plants that need the regular rainfall, right? I mean, plants need what, an inch a week, inch and a half a week if they're in their really high growing period. And so if you don't get any rain for 3 weeks, as sometimes we go through a dry spell, the plants are going to respond to that as if they're in a longer drought. And so it's called rapid onset drought or flash drought, something that's become much more important. And there have been some laws that have been tied to drought. For example, there's payments to people who produce forage that are tied to the drought monitor. But the drought monitor does not monitor flash drought. They monitor drought that's really 3 months or longer. And so when you tie payments to something that is not really designed to measure that quantity, you get a lot of conflicts. Every time we have a flash drought, the cattle producers start calling me and saying, why is the drought monitor wrong? And they're not wrong. It's just they're not measuring what needs to be measured. And there's currently, I mean, they're working on ways to work around that, but people that make the laws are not usually scientists, and so they don't understand all the niceties of that. But I mean, flash drought, I mean, Florida already goes through a dry season, right? So you expect it to be dry, and then you might go into the tropical season in the second half of the year, and things will get a lot wetter, but it really depends on where those tropical storms go. I mean, in Georgia, we were just blown away this year because usually we don't have any tropical storms that come directly over Georgia. And this year we had 2.5. We had Debbie at the beginning of August, which dropped up to a foot of rain in some places. It was more of a rainstorm. And then we had Helene come through pretty close to the same places. A little bit, the path was a little bit different. Helene was a little farther to the west. Helene also dropped, 8 inches or more in some places, but it also had the really strong wind. So we had much more wind damage from that. Um, but in between, it was really dry. So it was feast or famine the whole year. We had, and the problem is, if you get 8 inches or 12 inches of rain in 2 days, and then you have to average it over a whole month, it might actually look like it was an average month, but that doesn't really capture the story of what's going on. And so, yeah, so the drought monitor is more looking at the long-term averages, and all that tropical activity just kind of blends out. And with Florida too, when you had Milton come over, then there was a lot of rain there, and that cut back on the drought in that location. But other parts of Florida, in fact, right now I think most of Florida is in drought, and that's even based on the long-term drought.
Thinking about how we can apply that to our invasive species management, and especially saying that the drought levels may reduce herbicide uptake. When we're in situations like that, we might need to use a higher percentage on our invasive treatments. What are some symptoms in the plants that we can look for to determine if we do need to increase our herbicide rate?
Yeah, I'm not the herbicide specialist here, so I'm not sure I can answer that. I'm guessing that
Well,
the lack of effectiveness, probably.
Yeah, well, just thinking about the symptoms in plants, like a crop species, assuming there's some similarities between the crops and invasive plants. what are those signs that you're hitting the drought that people can watch for in the field? Is it just simple wilting of leaves, or is there something different to keep an eye out for on
Yeah,
the
I think wilting is usually one of the first signs that there's problems with the intake. Uh, our friends that are climatologists in other parts of the country think that when you're in a drought, there's dead cattle by the side of the road and everything is brown. But that's not what drought is like in the Southeast. You know, things can still be green, um, especially things that have more uh, spread out root systems or can survive better on little rain. And so we can still be green here, you know, until things are really bad. Then the wilting will become more obvious. Eventually, things will start to die. You will sometimes see increases in things like forest fires as the drought lasts longer, and you start to have a lot more dead vegetation. Um, and usually it's things that are fairly shallow rooted that are going to show it first. And then as time goes on and the water table gets lower and lower, you're going to see that affect other things more evenly.
So our grasses and forbs are the species that you're going to see impacted first, but then maybe a lot of our invasive tree species would be a bit more resistant to some of those
Yeah,
droughts.
I think it depends how deep their roots go. I mean, some of
Sure.
the invasive species are developed to have pretty long roots, and they can tap into moisture even better than some of our native plants can, because the native plants are used to getting more water more often because we do get a lot of rain here in the Southeast. And so I think that's something you should, I think it's helpful to look in your own yard. I keep track of, I'm not really a gardener, but I keep track of what the vegetation in my yard is doing. And you know, I can start to see the grass starting to get crunchy. Even after a week, you can start to see that there's footprints you can see in the grass that are not really coming back. It's a little longer than my vinca, which of course is an invasive species. Just all the leaves kind of just crinkle up and it doesn't grow anymore. Usually the trees are better because they have a more developed root system, so it takes them longer to really show the stress from drought.
Those are good things to keep an eye out. I'm thinking too, a lot of our staff are probably our land managers also involved with prescribed fire. And so, keeping an eye on the KBDI, our drought index,
Yep,
would be a good thing
absolutely.
to
Yep,
kind of keep an idea of how you might adjust your herbicide treatments.
yep.
We got another question. Could you speak a little more on changes to water temperatures in freshwater bodies? Is there any monitoring being done on major freshwater systems, or are all these temperatures being done on terrestrial stations?
Yeah, that's a great question. I hadn't really thought about that, but I mean, definitely, water temperature is going to be an issue for the kind of things that you'll see growing in or near those water bodies. And I would imagine the water management districts in Florida are probably keeping track of that. I know that the USGS sites where they're present will sometimes have water temperature sensors as well. And so that is something that they're watching. Here in Georgia, they have a whole group that monitors for the blue-green algae that can develop in farm ponds and lakes and so on in the summer when the temperature gets warm and it's really stagnant. They probably have something like that in Florida as well, but I would imagine it would be very piecemeal, that some places would do more monitoring than others would. But it would definitely cause impacts because the warmer water is going to affect the plants differently, I think.
One other question that I've had and seen, especially lately, seeing what's going in the Northeast, the polar vortexes and how those are kind of changing. So even though our average winter temperatures are increasing, we do get a lot of these really strong cold fronts coming through. I was surprised to have 4 inches of snow, almost 5 inches in the Panhandle last month. Not something I would have ever expected living in Florida. So how might that do we know if we'll see more of those with climate change, or any thoughts on the polar vortexes?
Well, you know, people ask me, it was supposed to be a La Nina winter this year. Everybody was expecting warm and dry conditions. And we were dry for the most part. I mean, the snow was kind of spectacular because there was a lot of it caused, weighed a lot. So it caused a lot of damage to nurseries in the panhandle of Florida and along the area where they had the most snow. But the water content wasn't very high. And so even though the snow looked interesting, and for people who'd never seen snow before, I'm sure it was great to see. Um, from a water balance standpoint, it wasn't that helpful to improve things. I think one of the things we're seeing this year is as the relationship or the difference between the temperature at the equator and the temperature at the poles is decreasing over time because the poles are getting warm faster than the equator is. And so as you get less of a gradient, you start to get these wavier weather patterns where you go through periods where it's more warm and then followed by periods where it's colder than it used to be. And so some people think, and the scientists are not all in agreement about on this, we're going to see more waviness in the winter months. So we'll have periods of really warm conditions, periods of really cold conditions, and that could increase over time. Overall, as the temperature goes up, we're going to have fewer and fewer of those. But we're not going to get rid of the chance of snow for a long time, I don't think, because there's still plenty of cold air to the north. And if that is able to come into the southeast, that if the ingredients are just right and you can get the cold air and the moisture together, then you can still have snow. I just think maybe it's going to be fewer than it used to be in the past, but I think it's going to be a long time before there's no chance of snow. And so I think that's something to keep in mind.
Hopefully some of those cold fronts might also help with kind of restricting some of that northward expansion of some of those tropical species.
Yeah.
So that might benefit us, maybe. We'll see.
Yeah, you like to think so, but we're starting to grow citrus in Georgia again. They didn't do it for a long time because of all the frost we had in the 70s, but we have fewer frosts now than we used to. So they're starting to grow more cold hardy varieties of citrus like satsumas. And no, we're not going to be growing limes here anytime soon, but we're starting to grow some of those. And they're also doing that partly because of the citrus greening. They want a separate population that they're trying to keep the citrus greening out of so that they can, another invasive species that they're trying to figure out ways to control it.
All right, do we have any more questions from our group? That was a fantastic presentation. Thank you very much, Dr. Knox.
You're welcome.
Information for us to share out, both from natural resources, agricultural, and society. So thank you for the work that you do.
Yep, thank you.
And give me a second. Now to continue on with our SISMA, FISP and SISMA updates. Can y'all see my screen okay? We have a lot of great events coming up in the next month or so here in Florida. Tomorrow we have our FISC-PAC biannual meeting, and then a lot of great work days and public outreach events as we're getting into our nicer weather. We are well into spring for a good part of the state. Looking in even farther out into a little bit more into March, again, more outreach events and planting. We do getting to see some SISMA meetings going in. And of course, middle to late March, we have our FISC annual symposium. If you're not registered for that yet, I encourage you to check it out and sign up soon. And of course, with National Invasive Species Awareness Week, we also have our weed wrangle events here in Florida. And we've had a few that have happened already and great results coming out of those. But there's still several great events around the state if you want to get out and help actually see some work out on the ground and network with local land managers in your area. As far as announcements, UF is doing their invasive ant boot camp again in this May. The registration is up. You can find more information on their website listed there. And also UF Assessment is looking at increasing a few more of their species, updating some of this information. So we've got, I think, about 10 different species that are on the list here that they're requesting land managers to provide additional information on. So if you work with these at all, if you've managed, if you have experience, it's really helpful to the folks at the assessment to get that knowledge that you have from your real on-the-ground management. So reach out to Dr. Sakman Kim at UF if you'd like to participate. And this information will also be shared out in my monthly digest next week. So you can get that then if you're not able to copy his email address down right now. And then finally, we have a lot of great calls coming up for the rest of the year. Next month, we'll be talking about the avian vacuolar myelinopathy update and learning how that has changed in recent times. All of our calls are recorded and are updated on our YouTube channel, so you can go back and watch this or any of our other fantastic presentations at your leisure. And that is everything that we have for today. So I want to thank you again for making time. Thank you, Dr. Knox. Thank you to all of you. Hope you have a great National Invasive Species Awareness Week, and we'll see you around. Have a great day.
Thank you. Bye-bye.
Thank you.